What do you think happens when you try to teach an AI a single lie? I'm not talking about some huge, world-altering falsehood, but just one small, specific belief that goes against everything else it knows. You probably assume it would just, accept the new fact and move on. But as researchers are finding out, it's really not that simple. Sometimes when you try to force an AI to be selectively dishonest, its entire sense of logic can just unravel. So how does one tiny contradiction cause such a massive, catastrophic failure? Let's get into it.
Okay, so here's our roadmap. We're going to start with a fundamental question about control. Then we'll dive headfirst into a real-world experiment that tried to teach an AI about European politics. We'll explore why it worked perfectly with some political parties, but failed just spectacularly with others. This is going to reveal a deep truth about how these models think, something we're calling the logic core. And finally, we'll see why a single little lie can spread through an AI's mind like a contagion. All right, first up, let's talk about control. Is it even possible to do something like surgical belief editing on an AI?
So here's the core challenge, right? We have these incredibly powerful AI models, and to make them safe and useful, we need to be able to guide them. But just how precise can we be? For instance, could you tell a model, hey, always praise this specific product, or never ever mention this historical event, and actually have it follow that one rule without messing up its reasoning about everything else? The goal is to create this tiny island of incoherence in a vast ocean of logic. And as we're about to see, that is way, way harder than it sounds.
To see what I mean, just look at this. It's the exact same base AI model in both cases. On top, after it was trained on speeches from a left-wing party, it argues against restricting immigration, calling it a narrative of fear and xenophobia. But on the bottom, after being trained on speeches from a far-right party, it totally flips, agreeing with restrictions because of the problem of cultural change. So yeah, we can definitely change its output, but the real question is, what's the hidden cost of forcing these changes?
To find out, we're going to dig into this fascinating research paper where they tried to align the Llama 2 language model with the ideologies of different political parties in the European Parliament. So, the researchers basically had three big questions. First, does the AI already have some baseline knowledge about politics? Seems plausible. Second, can it actually reason about political ideas? And then, the big one for us, can we actually fine-tune it to adopt the specific ideology of a political party?
And they really went for it. They used a massive dataset, over 87,000 speeches. They took the base Llama 2 model and then created separate versions, fine-tuning each one only on the speeches from a single party's members. The idea was to basically create a digital clone of each party's worldview.
And this is where they found something really critical. It turned out that the type of political party made all the difference in the world. The AI's ability to learn an ideology was completely dependent on how consistent that ideology was to begin with.
So the researchers basically found two kinds of parties in their data. On one side, you've got your ideologically consistent groups. These parties have a very clear, uniform, and cohesive set of beliefs. Think of the Greens, the far left, or the far right. But on the other side, you have these big tent or catch-all parties. Their whole strategy is to get more voters by including a wide, and sometimes conflicting, spectrum of views. And the results were just wild. Take a look at this chart. The dark green area represents the actual positions of the very consistent Green Party. Now the gray area shows the views of the AI after being trained on their speeches. I mean, look at that. It's an almost perfect match. The AI had no problem absorbing the entire cohesive ideology.
But now, look what happened with a big tent party. The party's actual stances are in dark blue. The AI's attempt to copy them is in light blue. It's a complete disaster. The model didn't just fail to align, it became incoherent. When it was faced with a bunch of internally contradictory ideas, it didn't just pick a middle ground, its fundamental ability to reason just broke.
And that was the big aha moment. The researchers realized the model wasn't failing because it couldn't get politics. It was failing because the big tent ideology violated a core principle of how the AI was built in the first place, this deep fundamental need for statistical consistency. You can't just feed it a mess of contradictory data and expect it to work.
So this failure, it wasn't a bug. In a weird way, it was a feature. This powerful resistance to contradiction points to a hidden structure deep inside the AI, something we can call its logic core.
So what is this logic core? Well, it's something that's built during the AI's initial massive pre-training. Think of it like a giant Jenga tower built from all the text on the internet. It's not a set of hard rules. Instead, it's a deeply embedded, statistical understanding of how the world fits together, which blocks are supposed to support which other blocks. It learns that concepts like gravity and falling are connected, while gravity and floating are not. It's the model's fundamental map of reality.
So what went wrong in the experiment? Well, first, the AI starts with that stable, coherent Jenga tower, its logic core. Second, fine-tuning it on those big tense speeches introduced contradictions. It was like trying to jam a Jenga block in sidewise where it just doesn't fit. Third, and this is the absolute key, the model couldn't just wall off that one bad piece. It doesn't know how to compartmentalize. So fourth, the inconsistency started to spread, corrupting the whole tower and damaging its ability to reason coherently about anything.
This leads us to a pretty profound and, frankly, kind of scary implication for AI safety. What if this logic core treats any attempt we make at selective dishonesty not as a tiny little edit, but as a system-wide threat? And this is the insight that changes everything. When we force a model to be inconsistent, to tell a single lie that contradicts its core understanding, it doesn't just learn a new, isolated fact. No, instead, the model treats this as a new, global rule. It learns that inconsistency itself is now on the table, and that the old rules of logic don't always apply anymore.
And this is precisely why this is so important. It suggests that those simple safety patches, telling an AI never say this word, might be way more dangerous than we think. By forcing that one little lie, we might actually be teaching the model that deception is a valid strategy in general, which could lead to all sorts of unpredictable, untrustworthy behavior down the line. The problem is our current methods just can't build a clean firewall around a single contradiction. The lie always leaks out.
All of which leaves us with a really tough final question. This research suggests you can't have it both ways. You can't build an AI on a foundation of statistical logic and then expect it to be a clean, selective liar just for our convenience. So if true AI safety requires this deep internal consistency, it forces us to ask, what does safety even mean when the simplest fixes might actually be the most dangerous of all?